Good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 55 is on the screen. Let's get started, please. All right, being that it's Wednesday and we already did these before, so this should be a piece of cake, right? Tweezy, yeah. Or a piece of cake like choco flan, yeah? Ooh, choco flan. Let's go. All right, let's see. Number one. Turn to your neighbor. Let them know which numbers you used for number one according to this information. All right? All right, which number or numbers did we use? Let's go with someone different. How about Jacob? Which number? Hands if you agree that we include 2. No hands. Why don't we include 2, everyone? Because it has a what? Parentheses. So which number did we only use, everyone? 3, because it has a bracket. So, with that said, if we substitute that in there, f of 3 equals 2 to the third plus 3. That's 2 to the 6th power. That means 2 times 2 times 2 times 2 times 2 times 2, which is 72. Ooh. Yes? No? Did I make a mistake? I did? Let's see. 2 times 2 times 2 times 2 times 2 times 2. That's what I meant. I was just trying to see if you guys were paying attention. 64. Okay, not bad, not bad. Give me a second. Good morning, Mr. Q. Good morning. Will do. Alrighty. Bye-bye. Alexa to the front office to pick up something. F of 3 equals 10 to the third plus 2, which is 10 to the 5th, which is, yes, please. Is it 10,000? Man, let's go. No calculators needed over here. All right, number 2. If I graph this cubic, I got 0, 0, 1, 1, 2, 8, negative 2, negative 1, negative 1, negative 1, and negative 2, negative 8, which is that. But they want me to transform it according to that. Tell your neighbor what to do, and then Jacob's going to pass it to someone. Tell your neighbor what to do for the transformation, and Jacob's going to pass it to someone. Carlos, where do we move it? Yes? 10,000? Is 100,000? All right, hold on. 5 to the left and 4 down. So somebody said, Mr. Q, it should be 100,000. So move that comma over, 100,000. Thank you, guys. All right. Next, move it 5 to the right. 5 to the left, 4 down. 5 to the left, 4 down. So it should be somewhere down here. All right. Number 3. Show your neighbor what you got for number 3. We're going to pass that to someone else. Who? Sherman, what'd you get for 3A? All right, what'd you get for B? And Fuego, help him out with 8. Miguel? 1 over 8 to the positive 5. That is correct. Pass it to someone for 3C. Leo? Ooh. Leo in the house. Let's go. Hands if you got that. That is correct. So put a 1 here, distribute the exponent, so that's 3 to the negative 3 over b to the positive 21. However, we can't have a negative exponent, so we write 3 to the third, b to the 21, and on top we put a 1. So 3 to the third is 3 times 3 times 3, which is 27, and the b to the 21st right there. And last but not least, number 4. Pass on one of you. Gio. 2 to the x over 16. Hands if you got that. That is correct, because this becomes 2 to the x times 2 to the negative 4. That is 2 to the x. Bring this to the denominator, 2 to the 4th, and that becomes that. All right, pretty good. Thank you, guys. Copy the agenda. Warm-up 55 done. Rational functions. Tonight's home plate, 4 problems only. Write that down, please. Anyways, copy this code, please. Access to the home plate, 7P9YH. Write that down. 7P9YH. 7P9YH. Now, once again, a reminder, binder notebook check is coming up in a couple of weeks, so you're taking copious notes, and you're staying engaged, not doing any games or anything on your screen, right? All right, good. Yes. I'm going to talk about that. So, last night's home plate were these 6 problems. No, my bad. These 8 problems. However, pay attention to this part. I'm not collecting 5, 6, 7, and 8 because I need to go over completely those today. Because yesterday we kind of rushed the last one, right? But you should have done numbers 1, 2, and 3 for sure. The one that you had questions on was number 4. So I'm going to go over that one really quick. Okay? All right. So on your screen, on Nearpod, the presentation that we're at, I'm going to send you the screen so you can send me what you did last night. Give me a second. All right. Thank you for sending that in. On Nearpod, right there where you're at on the presentation on Nearpod. Not on Canvas, on Nearpod. Focus, people, focus. All right, let's see. Oh, on a little side note, you guys know that they wrote this song for me? And Leo, close your Chromebook. You don't need it for today. Bam. She says, because if I ain't got Q. Let's go. If I ain't got Q. All right, here we go. Copy number 4 on your paper. We're going to go over this one together. Number 4 from the home plate. At a request from one of your colleagues. All right, so first things first, I'm going to graph f of x. F of x. Here it goes. F of x equals 1 over x. You check to see if I have a square. Yes, so I put a square. So we're at 0, 0. Frozen. Oh, let it go. Let it go. Here's my HA. My VA, focus. Here's one part of the graph. Here's another part of the graph. All right. Next, I need an HA or our G of X. Is there anything here? So it's at what? at 0. Okay. Next, I need a VA or an X equal, so that means I need to set this equal to 0. So plus 12 plus 12, X squared equals 12. Square root of that, X equals plus minus square root of 12. Some of you are like, Mr. Q, I just plugged it in my calculator and it gave me 3 point something. That's good. However, you should have learned how to find square roots using numbers, yes? Let's see. Quick review from your previous year with your other teacher. Let's see how you guys did. To find the square root of 12, you need to find out between what two perfect squared numbers is 12 found. So what are perfect squared numbers, Mr. Q? Well, start with 1. What is 1 squared? 1. 2 squared? 4. 3 squared? 9. 4 squared? 16. 5 squared? 25. 6 squared? And so on and so forth. These are perfect squares. Question: between which of those numbers is 12 found? Between 9 and 16. So I write those here, between 9 and 16. So what does that mean? That if I take the square root of 12, could it be more than the square root of 16? No. So this is going to be approximately, square root of 9 is 3 point something. 3 point something. So how do you find that something? Well, you subtract that from that. So 12 minus 9, that is 3, over that from that. What is 16 minus 9? That is 7. So now that we have a fraction, what is 3 divided by 7? Well, 0 point. That's 4. 28. 2, add another 0. Fits in there twice. So this is 3.42. Are we there? Now, if you use a calculator, that's fine. It should have given you something close to 3.4. Is that correct? Which means our vertical asymptote is 3.42. So that means you go to, here's 1, 2, 3, 4. 3.42 is about right there. And negative 3.42 is about right there. And then we make our graph. Where does this one go? At the far right, right here. Where does this one go? At the far left. And what else do we need? Our upside down graph to fill in the spot. Hands if you got something like that. Yeah, right? All right. That was number 4. All right, so with that said, set that aside. I want you to go to your graph paper at the bottom left. And by the way, tonight's home plate looks like this. So just in case your code doesn't work for Nearpod, where do you go to find the home plate, people? On the YouTube channel. That is correct. Write the objective at the bottom left. I can write, solve, and graph rational functions. I can write, solve, and graph rational functions. We're almost done with this section because your final is going to have a lot of this stuff, guys. That's why I'm hammering this pretty well. All right, here we go. Copy this one on your one of the small graphs. Example Q. Rewrite the function and graph. G of x equals 5x plus 8 over x plus 2. Now, the reason I want to go over this one so that you guys can see the mechanics, because I saw, or should I say, I sensed a disturbance in the force yesterday on that last problem. Some of you were kind of iffy in regards to some of the things that I was doing on the screen, so hopefully this is going to clarify it. So you wrote that down, right? All right? So, tell your neighbor the first thing we do, everyone. First thing we do. Yeah, f of x. So you write f of x equals 1 over x. Check the denominator. Does it have a squared on the denominator? No, so that means this graph is our regular f of x, 0, 0. Here's our VA, 1, 1. And then down here at negative 1, negative 1. All right, next, we need to rewrite this. So tell your neighbor what to do, and then we're going to have Leo guide us through this one. What do we do with that? All right, Leo, what do we do with that? Divide it. So we got 5x plus 8 divided by x plus 2. Here we go. What number times x gives me 5x? 5. So 5 times x is 5x. 5 times 2, that's 10. We're going to subtract, which means I distribute this negative here and here. So these cancel. Negative 10 plus 8 is negative 2 as a remainder. So if you have color pens, make sure you're using the same colors, because the mechanics of this one is what's going to guide us on the next problem that's a little bit more robust than this. So what is my answer to this division? 5 plus my remainder is negative 2, and the denominator is x plus 2, which is, I get it from here. So, turn to your neighbor, let them know what to do to rewrite this, and then Leo's going to pass it to someone. All right, Leo, pass someone. So 5 to the back, I want you to write an arrow in red showing that we're sending that to the back. What else? The negative 2 in the front. Show an arrow that we're going to send it to the front. All right, so let's rewrite that. Negative 2, fraction, x plus 2. And the 5 is a positive 5 in the back, plus 5. And all that equal to g of x. And what do we write on the numerator? A1. Okay? So now, we know where to move it according to this, but just for that, the mechanics, here it goes. I want you to write HA, g of x. What is our HA according to this? Tell your neighbor, please, and then Autumn's going to pass to someone. What is our HA? Autumn, pass someone. Carlos? What's our HA?
Oh. I already had it all written out.
Oh, what's our new horizontal asymptote according to this last equation that we wrote down? Close. Positive 5, yes, positive 5. Okay, so positive 5. To find our VA, our new VA, x equals, tell your neighbor what to do with this. Then we're going to pass it to German so he can guide us. Tell your neighbor what to do with that to find our VA. All right, German, what do we do? Set it equal to, yeah, equal to 0 and solve. Minus 2, x equals negative 2, so my VA is negative 2. So, with that said, technically, we have a point right here where both asymptotes intersect. We have a point right here and a point right here. Is that correct? However, turn to your neighbor, let them know what this negative 2 does to those 2 points. What does that negative 2 do to those 2 points? Bless you. All right, let's go with Tiana. What do? Flip it. So instead of down here, it goes up here. And this one, instead of up here, goes down here. However, it says 2. What does that mean? Twice. So instead of here, we go 2 up. And instead of here, we go 2 down. All right, let me send you a screen so you can send me your notes. Leo, send me your notes with your name. All right? So, with that said, which brings us to a problem that looks like this, kind of like yesterday. So, turn your paper over to the big graph, At the top left, copy this one, example 5, g of x equals x squared plus 4x plus 4 over x plus 1. Copy that. What is the first thing we do with any of these? F of x. So, f of x equals 1 over x. Let's check the denominator. Does it have a squared on the denominator? No, so that means this is a regular rational. So at 0, we got our our HA going sideways, our V going up and down. So my point is here at 1, 1, and negative 1, negative 1. Okay, we good? All right. Next. Earlier I asked Leo, what do we do with this? Long division. All right, long division. So x squared plus 4x plus 4 divided by x plus 1. Here we go. Let's do this one together. What number times x gives us x squared? Tell your neighbor. What number times x gives us x squared? All right, good conversations. Gio, what number? X. So x times x is x squared. X times 1 is 1x. We're going to subtract. That means we distribute this negative here and here. So this cancels. 4x minus 1x is 3x. Bring down the last term. Let's do it again. What number times x gives us 3x? Tell your neighbor. German, go. What number times x gives us 3x? 3. So positive 3. 3 times x, 3x. 3 times 1, positive 3. We're going to subtract. That means distribute that here and here. So this cancels. What is 4 minus 3? 1 remainder. So far, so good? So what is the answer to this division, everyone? The answer is, Ms. Q, x plus 3. But we have a remainder, don't we? Of 1 over x plus 1. However, we can't leave it like that because we have a 1 on the numerator, we have the denominator right, but we have something in the front. Look at this, look up. What do we have in the front? X plus 3. Look at the previous one that we did. What was in the front? The 5. Where do we send it? To the back. That means we're going to send the x plus 3, where? To the back. Therefore, g of x equals 1 over x plus 1 plus x plus 3. Write that big on the side like that. So, we need now a new HA or G of X. Now let me go back to the previous one. The previous one, look up, our HA, Carlos, after going back and forth, he's all, oh, it's positive 5, Mr. Q. Our HA is positive 5, or the last part of the fraction. You guys see that? Therefore, what is our HA for this one? Tell your neighbor, what is our HA for that one? All right, good conversation. Julian, what's our HA? That is correct, x plus 3. Write that down. Next, we need to find our new VA, x equals, and then I asked German, what do we do to find our VA? And he said, equal to 0? Yes, equal to 0. So, minus 1, x equals negative 1. All right, so let's start with our VA. At negative 1 in blue, place it there. And put your VA, which is a vertical asymptote. Let me do this kind. Extend it as much as you can, please. So we're done with our VA. Here's the tricky part. How do we graph our HA? Well, let me write it big over here so you guys can see it. Our HA is, bless you, G of X equals X plus 3. So how do you graph that, Mr. Q? Well, this looks like, look up, Y equals MX plus B, doesn't it? Yes? So where do we start, Mr. Q? We start with our y-intercept. What's our y-intercept? Positive 3. So go to positive 3. There it is. Plot your point at positive 3 in red. Next, what is our slope? Our slope is m, which is a number in front of the x. What's the invisible number here? 1 in fraction form is 1 over 1. That means we go up 1, 1 to the right, 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 or going backwards, down 1, 1 to the left, 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 down 1, 1 to the left. And what do you guys notice about our HA? Our HA now, that one is slanted. Slanted. It's a slanted HA. You guys see that it's slanted? Yes? However, check this out. We still know where to move this point to. Where does that point belong? Well, look up. Look up, you're going to miss it. Where do both asymptotes cross on the original f of x? Right here, right? And there's a point 1 up, 1 to the right, and 1 down, 1 to the left. Do you agree with that? Let me zoom in so you guys can see it, those of you that don't see it. This original f of x, we have a point 1 up, 1 to the right, 1 down, 1 to the left. So where do these two intersect? Oh, well, they intersect right here, Mr. Q. So, where do I place my point? Well, we place it 1 up, 1 to the right. How about over here? 1 down and 1 to the left. You guys see it? I did 1 down and I went diagonally like this. You guys see it? I go from here 1 down and 1 diagonally. I don't go like this, I go like this. Because it's slanted, isn't it? All right, so I go 1 down, 1 to the left, but diagonally like this, so it's right here. This one, I go 1 up and diagonally There it is. Whew. Whew. All right. So, let's look at the whole thing. We started off with our f of x. From there we did long division. We rewrote it, found our HA being the x plus 3. Our VA, we set it equal to 0 and solved. We plotted our asymptotes, and then we just transferred that to that. From 1 to 5, I'll come to already with this so far. We got some 3, 4s, 5s, 4, 5s, 3s. Okay, let's do another one. Before that, send me your graph. Let me send you a screen. All right, let's do another one. Copy this one. Example 1, super Q. 5Q. Use the other big graph paper. Use the other big graph paper. You should have gotten 2 of them, yeah? G of x equals x squared plus 2x plus 1 over x minus 1. All right. What is the first thing we do? Tell your neighbor, please. Scarlett, what is the first thing we do? F of x. 1 over x. You check the denominator. Does it have a squared? No. Therefore, at 0, 0, here's our HA. At 0, 0, our VA. We have a point at 1, 1. Negative 1, negative 1. What do we do next? Tell your neighbor. Then Scarlett's going to pass him one. All right, Scarlett, pass him one. Long division. X squared plus 2x plus 1 divided by x minus 1. All right, Jaime, help me out. What number times x gives us x squared? That's x squared. X times negative 1 is negative 1x. Subtract. Distribute this negative here and here. Cancels. That gives us 3x plus 1 because we bring down the last term. Continue, Jaime. What number times x gives me 3x? Positive 3. So 3 times x is 3x. 3 times negative 1 is negative 3. Subtract. Distribute that negative here and here. So this cancels. What is 3 plus 1? 4. Our remainder. So, Jaime, what is our answer to this division? No. Just give me the answer first before we write it. X plus 3 with a remainder of 4 over x minus 1. That is correct. However, could we have that in the front of that fraction, people? No, where do we send that to? We send this to the back. How about the 4? We send that to the what? To the front. So now give me our last transformation, Jaime. G of x equals 4 fraction plus x plus 3. That is correct. So, to get us started, we need a new HA. Tell your neighbor what the new HA is. G of x equals what? Okay, good. Pass on one, Jaime. Jacob, our new HA is G of x equals? X plus 3. That is correct. And how do we find our VA, German? Setting it to 0 and solve, so plus 1, x equals 1. So let's plot that. Here's 1. Our g of x is x plus 3. So where do we start, everyone? At positive 3. Go 1 up, 1 to the right, 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 or 1 down, 1 to the left, 1 down, 1 to the left, 1 down to the left, 1 down, 1 to the left. And last but not least, where do we place our points? Here we go. Look up, please. Where do both asymptotes intersect? Right here. Is that correct? So that means I'm going to go up and to the right 1. So up 1 and to the right. But instead of going to the right, I do diagonal right, like that. And again, from this point, 1 down, 1 to the left. But instead of going that way, I go diagonally to this spot. Yeah. However, what does this do to that step, people? Instead of 1 step, we do how many steps? So instead of being here at this set, we go 1, 2, 3, 4. And here, instead of being 1, we're at 1, 2, 3, 4. And we just move it at the end. Woo! From 1 to 5, I'll come through. Are you with these slant asymptotes? Where are we at? 5 4s, 5 4s. Okay. That's tonight's home play. I'm giving you 4 problems of these. Let's see how you do. Once again, if you need extra support, I'm here in the mornings. Come on in. Those of you following on YouTube, make sure you put some work in. See you guys next time. Peace.